In this tutorial, we're going to discuss solving trigonometric equations. And just so that we can all talk in the same units, we are going to work strictly in radians in this particular unit. So that doesn't mean that there aren't answers in degrees as well, but we're just going to work with radians. Example 1, solve the equation for all solutions on the interval 0 to 2 pi. That means that your answers should be within this interval. So the sine of x equals 1/2. We know that to isolate our variable x, technically you would be taking the inverse sine of both sides. So we'd be taking the inverse sine of 1/2, and the inverse sine of the sine of x isolates x for us. Now, what we don't want to do is just rely on what you would get if you would type this in the calculator, for example, because of what we learned in our last class, that our calculator is set up in a very strict range, and we're not actually in that range here. We're working on this interval. So you're going to have to think through on the unit circle about all angles within that range, 0 to 2 pi, that have a sine of 1/2. And we know the sine is your y value. And that occurs here at pi over 6, and then also over here at 5 pi over 6. Nowhere else on the unit circle between 0 and 2 pi is there a sine value of 1/2. So those are our only two solutions on that interval. But if I change the question and instead of having this interval, if I asked you for all possible solutions, we have to start considering coterminal angles. So I know that pi over 6 is coterminal with infinitely more angles, right? I could add 2 pi repeatedly. So if I added 2 pi, which is equivalent to 12 pi over 6, I would get 13 pi over 6. Or I could add it again and again, or take it away. Same thing with 5 pi over 6. I could add 2 pi repeatedly. So 17 pi over 6 is an example of something coterminal. These angles also have a sine of 1/2. So they would also work in this equation if I were looking for all solutions versus just on this interval. So how do I write that? Well, we take our answers, pi over 6 and 5 pi over 6, and just like how I got 13 pi over 6 here by adding 2 pi, we're going to say for each of these, we would add 2 pi, but we want to show that you can add 2 pi any number of times repeatedly. So we would put another variable there, in this case, n, where n would stand for any integer. So if n was 3, that means you're taking 2 pi and you're adding it 3 times. And we would do the same thing for 5 pi over 6, 2 pi times n. And because n is any integer, and an integer could be positive or negative, this also takes into account if you would be subtracting 2 pi repeatedly. So x could be pi over 6 plus 2 pi n, or 5 pi over 6 plus 2 pi n. And again, this is if we wanted all possible solutions, not just solutions on this one interval. So let's look at another example. The tangent of x equals square root of 3. And here, again, we want all possible solutions. So in order to answer this, of course, we could go ahead, we could take the inverse tangent of both sides, which is technically what we're doing in order to isolate x. But honestly, I don't really write this step each time anymore. I know that's technically what I'm doing, but instead, I like to just think through in my head because this is not something you're going to be using your calculators on. So instead, I want to think through where on my unit circle do I get a tangent equal to the square root of 3? So remember, tangent is y over x. And the way that that's going to happen is if we take root 3 over 2 and divide that by 1/2, right? That's going to give us a root 3. So think about what point or what angle has a terminal point 1/2 comma root 3 over 2. And we know tangent is positive. All students take calculus, so positive in the first quadrant and in the third quadrant. So I know that this occurs here at pi over 3. And then to be positive, they could both be negative down here in the third quadrant at 4 pi over 3. But if all I did was list pi over 3 and then 4 pi over 3, I'm not giving all solutions. So it's a good starting point to start on that interval 0 to 2 pi because that's just one full revolution around the circle. But now think about how could I write this? So again, as soon as it says all solutions, you take the ones that you found on this interval, 0 to 2 pi, and you add 2 pi repeatedly. You add 2 pi repeatedly. So this would be one way to write that answer. Now, in this case, there is actually another way to write the same exact thing. And what you can notice is that pi over 3 here, if I add pi to it, which is 3 pi over 3, I land on 4 pi over 3. And if I add pi again, I land back here coterminal with pi over 3. So if I keep adding pi, I'm going to bounce back and forth between these two angles or what's coterminal with them. So another way to write this is you could pick one of them, for instance, pi over 3, and you could technically add pi instead of 2 pi n times, and you're going to bounce between both of them. This is correct, so is this. So if you like shortcuts, this might be your way to go. But that doesn't mean that this is wrong, it's just another way to write it. And again, the only reason this works is because these two angles are pi radians away from each other. Solve for solutions on the interval 0 to 2 pi. So in this case, we're trying to solve for x. So the first thing I'm going to do is add 3. So we have 4 times the cosine squared of x equals positive 3. Then we can divide both sides by 4. So cosine squared of x equals 3/4. So if I want to isolate cosine, then I would have to square root both sides. Remember, when you're square rooting both sides, you take both the positive and negative square root. So that means that the cosine of x equals both positive and negative. And remember, when you're square rooting a fraction, you square root the numerator and square root the denominator. So root 3 over 2 because the square root of 4 is 2. So in order to solve for x, we need to be thinking about which angles have an x value, which is your cosine, of root 3 over 2 or negative root 3 over 2. So again, we are on this interval. So that means a positive root 3 over 2, that occurs at pi over 6 and at 11 pi over 6. And then a negative root 3 over 2 occurs over here at 5 pi over 6 and then at 7 pi over 6. So all of these are our answers on the interval from 0 to 2 pi. So we would say x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. You would have to list them all out like that. But if we wanted all solutions, you have a few options. If you just want to do the same thing every single time, then that means you write all of these out, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, and you add 2 pi n times to each one. This will always work if you're just switching from a certain interval onto all solutions. So all of these written out this way, that's one possible way to do it. A second way to do it, a shortcut, is if I notice pi over 6 and 7 pi over 6 are pi units away from each other. So if I take one of those, and you could say either one, I'm going to use pi over 6. If I add pi repeatedly n times, that's going to bounce back and forth between these two angles and what's coterminal with them. And then notice that the same thing is true about 5 pi over 6 and 11 pi over 6. They are pi units away from each other. So if I add pi repeatedly, I will bounce back and forth between those two coterminal angles, or angles that would be coterminal to those, I guess I should say. So you could write 5 pi over 6 or 11 pi over 6, and then add pi n times. And again, just remember that that n just is an integer, any integer. So this would be the same thing as this one, it's just your preference. You want to have to write more or a little bit less.